G'day everybody and welcome back to my channel. Don't worry, I'm not about to bore you guys watching me change your op amps again on here. All I'm gonna do, I've already started. I'm just trying the master side first. That's an LM 301, 301, 301. Oh, I didn't bend that over like that. Now I'm just about to populate this one. I still got my one mic caps on them. And I'm just reusing my same bits of wire to move the pads over to their original location, so that works out. I don't have to change anything else. And then when I go to stick new op amps in there, I can just move the wires back. I don't have to modify any more traces, so that's good. Because, let's face it, it's already a bit messy anyway. Yes, I'm going to clean up this flux. You guys might notice when I do soldering, say, here in the power area, I might give it a rough clean up, but I'm really fussy around there. It's honestly, it's just because it's a high impedance circuit and the op amp inputs are sensitive, so any contamination between them can affect the performance. So I'm really fussy around sensitive circuitry. But so the point I'm getting at is I will clean that up. It's not going to be all covered in flux between the pins like that and dirty once I'm done here. Anyway, so I'm going to put these in, see how it works with these references, because these have got no compensation capacitors on them. And look, to be honest, I'd imagine that just the capacitive loading of the circuit's going to be somewhere in the unstable region. It might not be, I could be wrong, you know, but I'd rather add capacitance to the references, you know. Actually, to tell you the truth, adding capacitance to a reference, if it's in the feedback circuitry, which this is, actually helps your power supply, because the reference is a device that only lets power flow one way, basically, right? It doesn't have very good AC characteristics. You want your feedback loop to have good AC response, not just DC response, right? Now, capacitors will couple AC across things. So sometimes when you're designing a power supply, if the reference is in the feedback network like this, not just putting capacitor on it for stability reasons, but it can actually also help with the AC performance of the power supply. And when I say AC for performance, yes, it's DC, but say you put an oscillator on it, say you put a switch mode power supply on it, anything that's pulsing or bringing the voltage and current up and down, whether it's in any sort of wave, right, that's still AC. It's an alternating current. It might be starting at a 0 volt point and going up to 12 and coming back to 0. It might not be differential, but it's still not DC. You can't even really consider it pulsed DC unless it was literally just, you know, sharp pulses. But look, it really depends how you want to think about it. But the point I'm getting at is when you've got a voltage going up and down, that's going to go through a capacitor. So adding a capacitor across a lot of things like pots, VREFs, stuff like that in your feedback network adds a lot more performance to the feedback network. So there's a couple of reasons I'm definitely gonna do that. And I mean, like I've got the spaces for them. Actually, on these top two, I haven't really got anything I've worked out yet for what I'm going to do. I think I might just drill 2 holes there for the electro and put the electro there, and a little high frequency mono or MKT or whatever, slap it across the back of those 2 terminals. But I'm not going to do that until it's powered up and I've got the scope on it and I can actually see what effect it's having live, you know, like whilst it's powered up. So I'm going to stop the video now whilst I finish doing what I said I was going to do, which is put the LM301s back in and then slowly change them out with other op amps and see if that even works. Yeah, I might even just leave them in there. I don't know, I haven't made my mind up too well yet. When I had a look at the data sheet for the LM301s, they can actually do alright in terms of performance. I mean, I was more worried about the current sensing circuitry's performance, but to tell you the truth, with a 1 ohm resistor, it wouldn't really matter how shit your input bias or your input offset voltage is on the op amp. It's still going to be able to measure a pretty big drop across a 1 ohm resistor. Like almost any op amp's going to be able to do that. So, you know, I don't think actually the constant current circuitry is going to be that much worse with them. I think the main improvements are the parts I've already added to it that are not op amps. If I can get fast op amps in there, that would be great. But who knows, you know. That's just something for the future. Like I said yesterday, I'm most likely just going to try and get this up and running, compensate the references, and stick it on my bench and get to work, because I've got another power supply I'm designing from scratch I need to finish. I've got amplifiers that I need to build and I need to repair. I've got that mixer that we're working on. I've got so much stuff to do. Low noise differential amplifiers I need to finish. I've got all these different things I need to get done. So yeah, that's where we're going from here, unfortunately. But yeah, no, I'm not giving up on it. There's going to be plenty more on this. Put it this way: as soon as I get it working, like I said, I'll get a couple other things done, and then we'll be diving straight back into this and seeing if we can get any better parts in it or not. Hey, just a little tip for people: when you're soldering this sort of wire, I know I hit the iron on that and the insulation's ruined, but when the plastic goes back from heat, if you pull it back down and hold it there and blow on it, right, it'll actually go all the way up to the joint and stay there. The heat makes it. I'll do the red wire. I'll do the positive wire again. Just watch, because this is a good little tip. It saves you having to recut the same wire like 10 times when you're doing what I'm doing, and you're unsoldering it and soldering it and desoldering and desoldering, whatever you want to call it. You know what I mean? And you don't want to have to keep recutting a piece of wire. But every time you put heat to it, look, I'll hold the heat on a bit longer. You see how the insulation's, it'll go even back more, see? But if we bring it back down with something cold, right, and blow on it as we cool it off, it'll go right back up to the joint and insulate it nicely. Just a little tip for you out there. Sure most of you already have worked that one out, but it is handy, and some things it's the little thing. Sometimes it's the little tips and tricks in life that actually help us out and go a long way. So, you know, just in case no one, or someone hasn't, no one, that was the wrong word. In case someone hasn't figured that one out yet, there you go. It's a nice little trick. It'll save you re-stripping bits of wire every time you're trying to do little bodge wire work, and you're trying to move the bodge wire a million times and the insulation keeps going back. The other thing you can do, of course, is cut the solder and cut the copper wire and cut it shorter. But the thing is, if you do that, then you've still got to re-tin it, and then the insulation just shrinks back further. So this is actually a good technique. Yeah, I'm going back in with the 0.1s. These are not the 1 microfarad ones, these are just the 0.1s. But I truly do believe the reason that those 10 nanos were there were for decoupling for the op amps. And, you know, back in the day, that's just literally, look, this isn't me just saying this. You can go read articles, watch videos on it, do research on it, you'll see what I'm saying. But yeah, back in the day, that was the general consensus. But yeah, now we do it a little bit differently. Not just because they were wrong back then. It's not that they were wrong. Capacitors were a little bit different back then too, you know. So whilst electrolytics were a lot of the times better in terms of ESR and stuff than the ones we have now, and in other cases worse, a lot of the smaller technologies like ceramics and stuff like that, they were nowhere near as good as they are now. So you would have to use a wider range to cover a wider frequency and get that ESR and get that good rejection over a whole frequency range. Whereas now, you can measure the ESR as, say, a 0.1 or a 1 microfarad monolithic or an MKT, and the frequency range that goes over compared to, say, you know, just a normal ceramic from say 50 years ago is insanely different, you know. So, you know, it's not that they were wrong back then, it's that we have different parts now that just function a little better. But that's the reason, if anyone's curious as to like my complete reasoning for doing that, going back in with 0.1s, that's why. And look, based on current draw and all that sort of stuff, these op amps are just running pretty much as normal op amps. Their current draws, you know, nothing special. It's the same as most op amps. And in this scenario, you usually would decouple an op amp with a 0.1. Unless you're worried about it actually causing some sort of a tank circuit oscillating, which I'm not. Yeah, that's the value you would use anyway. So I feel pretty comfortable doing that. Anyway, that's one side done. So let's just have a quick look. That's the reason I did the master side is because the slave side's the one that warms up like slowly. It's got that extra pin. It's a bit funny. The master side doesn't have anything wrong with it at all. And if you, how do I explain this? If you put it in independent mode, it truly does just behave as a good working independent power supply, if that makes sense. So you can't go wrong, so to speak. So I can actually just test half of this, essentially doing this way. I'm just going to install this. I'll be back in a sec. I just want to say, don't worry, I'm not silly enough to put it in auto tracking whilst I've got two different op amps on each side, because they could go into wild oscillation and do funky things and perhaps destroy or damage op amps that are in there. Yeah, so don't worry, we're just going to literally test the master side. Sorry, it's all in here, it's fumbling around a little bit. I should have moved this in the first place. My phone's flat. One sec. I just need to move my charging cable so that I can move my phone around more for you guys. There we go. Right. So, volts, independent, current's up, voltage is up. Well, both sides are working. Actually, that's hilarious. The right side, the voltage is too low. It's like I'm going to have to take the calibration pot back off of it. I bet you it's working perfectly normal now. I wouldn't be surprised, eh? I'm just going to test something quickly. I'm just going to turn the voltage on this master channel down to about 5 volts. 6 volts, somewhere around there. Put it onto amps. Oh, that's not good. Because I readjusted the offset. I was going to say, I thought the thing had somehow got a short on it somewhere because it was reading current. And then I was like, wait, that's not possible. Silly moment. No, that's just this pot. I think that's the one. No, my luck, this would be the one for voltage. And then I'll have to redo that. I did that the other day. I went to adjust the current pot. Turned out it was the one for the voltage. Ended up having to redo both of them. Just wonderful. Yeah, that's not moving it. I've just fucked up the voltage one. Now I don't even know how many count turns I was on because I slipped. Oh no. That was on voltage and it wasn't moving. So this is the amps one. Good. Still not moving. Oh, maybe, you know what? Remember how I was saying, I think, because of the weird power rails in here, op amps might be going outside the input conditions. I did have to turn one of these pots all the way around. What the fuck? Why can't I turn this? Yeah, what? Oh, I'm gonna know up all the brass. No. Oh, that hurt. Come on. damn it. It's not doing anything. Oh, that's the slave channel. Man. Wait, the slave channel that amps is on 0? Oh yeah, duh, because it's calibrated for TL072s and that's what's in there. Alright, that's a bit less confusing, so I need to somehow get to the other board without shorting everything out. Always fun. I'm just going to stick a book in here just in case something tries to touch the bottom of the panel or those two standoffs. Yeah, I feel a lot more comfortable holding the board in my hand like that with paper underneath it, and then I can just turn. Sorry, I'm trying to turn these pots here, you know, with it powered up, so you know what I mean? Yeah. We do what we have to do. So I'll now try again. That must have been for voltage. Oh man. You know what I'm going to have to do? Turn the voltage up to full. See what it measures. Yeah, that's reading different on the panel meter, so I'm going to have to readjust them all anyway. And once I get this thing working correctly, I shouldn't really need... You know, this thing is supposed to go up to 32 volts, I'd say. Or 31 point something, you know, around that ballpark. Most power supplies do, so it doesn't surprise me. You know what I'll do? I'll dial the pot down, the adjustment pot that I got on the back of the main pot, yeah, to 30, and then I'll set the panel meter to 30. That's definitely the wrong pot. Alright, I've got the right pot now. So I'm just turning it up so the panel meter is calibrated to 30. I don't need the meter in this tool now. I just realised I'm sitting there sitting funny and oh, that's not good. So, as you can probably hear those clicks, the pot's at the end of its travel, you can't turn it anymore. The panel meter's not going up all the way. I'm going to have to think about that one. That actually doesn't make sense. Unless one of the op amps, you know, like, could just be slightly buggered and still works, but not properly. That does happen with op amps. Yeah, that definitely isn't going up all the way. Let's see what amps is doing. Pot doesn't seem to be having any effect on amps. No. I'll go all the way to the other end because I have noticed with this circuit the effects the pots have on the panel meters is only right at the end of the pot. Like say out of like 25 turns, it's like the last 10 turns or whatever. It's not like the last turn, it's not that bad, but it's still not. No, this is working worse than the op amps that were in there. Okay, the amps is not working at all. And the volts is shy. Bloody hell, just... I think I'm going to go call this company now and see if I can get a schematic for this. This is starting to piss me off. Someone's definitely fucked with this. Excuse my language, but I mean, it's just blatantly obvious. The side that was double the voltage, they'd taken the 60 volt transistor out, put an 80 volt one in there. It's almost like, well, we're running it at 60 volts. Maybe we should, you know, increase the headroom of the transistor by 20 volts, you know. They put different pots in there. Just, everything was just, it doesn't make sense in this unit. I still don't even know that resistors that are in there that were changed are the right value. You know, the inputs to the op amps, they've got 4.7k resistors. Are they supposed to be 4.7k? I don't know. I think so, because I've had a look in other places on the circuit and you've got like 4.7k. So that's not 4.7k. I swear I saw 4.7k is going to the inputs of op amps. You know what, now I think about it, the only 4.7k's are the ones that someone's put in here. Damn. That would explain bias currents being off and stuff like that. Yeah. I'm tempted to just change that one op amp that's in the panel meter to another LM301. And you know what? Screw the panel meter. Let's see. Because the other three op amps I've changed are LM301s now on the master channel, and they control a constant voltage and constant current. Let's turn the current down. Let's turn the voltage down. I don't care what the panel meter's doing. We're ignoring that because that's not working. I'll turn the supply on. Wait, voltage all the way down. Oh shit! It's reading a considerable amount. Oh, what the hell? The panel meter has got such an offset on it. Okay, so that op amp must be partially buggered. That tells me that now. Now I can see the offset on it. I don't know what's going on with the camera on my phone, but I've been having problems lately. I've gone back to using the actual Samsung camera that like comes with the phone. I've gone back to using the original Video Merge app that I was using. It takes a really long time, but it doesn't seem to like... Some of the apps I was using, I record my videos all the same way, you know? And when I pick the phone up, you probably notice like I'm fairly conscious of holding it the right way. A couple of times I've turned it around. I'm not saying I'm perfect, and that's been my screw up, but a lot of the times when I merge my videos together, they're all the right aspect ratio, and then afterwards it just spits them out in random ratios. I don't know what the hell's going on, but that time it just stopped recording. I was like, okay, the storage is full. Storage isn't full. It just stopped recording for no reason. It was almost like the capacitive touch on the screen just fired where the stop button is. Alright, so I'm going to go to current. Looks like there's oscillation there anyway. So voltage is fluctuating around. It's a good sign. Oh, you should hear the sounds I'm listening to. Wow, that's coming from the series pass on it. Let's see what the current does. Holy fuck. I've turned the knob a quarter of a turn. That's half a turn. That's another half a turn. And then all of a sudden it dies off. Yeah, that's not working at all. Wow. Interesting. Alright. This is just proving useless. And I really can't be asked testing a whole bunch of LM301s any more than what I did the other night. I reckon they work and there's something off in here. I'm really leaning more towards there's something off in here. I've never ever spent this long on a power supply in my life. And it just, too many things don't add up. Too many things are questionable to me. I don't know. Alright, well, I'm going to leave this video here. I'm going to go call this company that Tanmera Tech suggested I contact, and I'm going to see if they can help me out with some schematics. If they can't, I'm running out of ideas, honestly. I'm not going to lie. At this point, it would literally be quicker, honestly, for me to etch up my own board and drop my own driver board in here. And just keep, you know, the chassis to transform with filter caps, output terminals, the knobs. I'd change the value of the constant current pot, obviously, and probably the constant voltage pot. Probably have a 5k pot for the constant current and a 50k pot for the constant voltage or something like that. But yeah, I'm really starting to wonder. It's just, yeah, this thing's got so many problems. It's getting to the point I'm starting to wonder if I've got leaky transistors or transistors that have got no gain, or yeah, like other things that are in the feedback loop outside of the op amps, because all different op amps are behaving totally differently, even the original ones that are in there. It just makes me wonder. Or is it really those references and they're just unstable in this configuration? I'm going to go call this company, see if I can get a schematic, and then I'll be back, alright? You guys are going to laugh at me. Probably already are. You know what I forgot to do, eh? I didn't put the compensation capacitors on these 1, 2, 3, 4 LM301s I just changed. They were probably oscillating and going like crazy. Because what I was just sitting on my couch drinking this watermelon drink, thinking about it. I called C-Tech, by the way, that company that Tanmera Tech found out used to be Scientific Electronics. I called them. They wanted me to leave a message and they're going to get back to me, so that's what I did. Explained my situation. Honestly, it doesn't sound like they're going to be very helpful. They didn't seem like they're going to be helpful, but we'll see. I got the feeling that they're not going to call me back, but we'll see. Anyway, I'll put the compensation capacitors on now and we'll try that again. I was sitting there drinking my drink, thinking to myself, hey, I wonder if the reference current for the top reference is still only 6 milliamps, 5 milliamps. And I came back in to put the boards in and power it up and do a quick test on it. And then I was like, hold on a minute. You didn't put the compensation capacitors on. So I'll do that now and we'll have another look and see if it works and if we can calibrate the panel meter on that master channel. I'll be back soon. Guys, I got the best news that we've ever had so far. So with the LM301s back in there with their compensation capacitors, I shit you not, yes, I did have to recalibrate it. But have a look at this. Oh yeah. But wait, it gets better. You're not going to believe this. You're not going to believe this. I know we've all been waiting for this day. Watch this. Ho, 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 ho. Oh yeah. And truth be told, because I just wanted to see if it would work. I just wanted to know, we still haven't even made the references quiet, so that's what we're going to do next. But look, I'll just be honest with you guys. I just wanted to know if it was because it was missing caps. All I did was grabbed an 82 picofarad and 150 picofarad and 150s for all the others and slapped them on there. They're not even the calculated nice polystyrene ones I'm going to put back on there now I know it works. and it's working. So it literally the whole time was what I said. Op amps out of range and oscillating. So, someone's at my door. This always happens to me. One moment. Alright, I gotta go deal with something. I'll be back in about, I don't know, 20 minutes or so. I'm gonna go do the same thing to the other side. All I've had to do is take the calibration pot off the constant current pot because it's already around 1 amp the way it was designed with the better accuracy resistors in there. It's literally at 1 amp and 10 milliamps. So I'm happy with that. And the voltage was going up to 31 or 30.88, so I left the trim pot on that to trim it at 30, so it's, you know, nicely calibrated and the meters are accurate. I've calibrated the meters. I'm going to go put the proper polystyrene compensation caps on there. I'm going to do the exact same thing to the other side, and then we'll come back and have a look at it. Hopefully it'll be working. We'll have a freaking power supply finally. God, imagine that. I just discovered something else. You know, I soldered the bottom tag on this constant current pot. This one's got the same problem, because if I hold it, you see, 0 milliamps. You see what I mean, eh? So that, what I'm going to do is exactly what I did to the other pot. I took this back plate off, and this last wiper here, there's a little brass, it's like a brass tinsel lead. Not a tinsel lead off of a speaker, but how do I explain this? It's just a flat piece of brass ribbon that's really, really thin, and it's just pressure fit to the ring that goes to that tab. And the problem with that is over the years, due to obviously plastic tolerances changing, so the press fit gets lighter, and oxidation and flux getting there from soldering it too long, as I explained in another video, it makes poor contact and you can't turn the pot down to 0 ohms. It's not actually the wiper on the coil in there. That can still go down to 0 ohms. It's just the contact. So I'm going to put all the LM301s back in it, install the nice polystyrene compensation capacitors, because the reason you want them in there is if you look at a data sheet from modern op amp, you'll see that it's frequency compensated, but it'll also tell you that it's temperature compensated for drift, for frequency compensation, and a few other things. And what that means is basically the compensation capacitor needs to be a really good capacitor that doesn't change its value or ESR characteristics too much based on temperature, because if it did, well, the op amp's compensation would be changing with temperature, and that would be really messed up. So that's why they're there. So I'm going to put all them back in now. I am free again now, so I'll report back very soon in about 20 minutes, but to you it will be 1 second, and hopefully we'll have 2 sides of this thing working, and then I can finally just do a test on it, you know. I mean, obviously I still want to put some caps on those references, but I want to scope across at the same time and make sure that they're not making it worse, obviously. That's a no-brainer. Other than that, yeah, I just want to put the polystyrene caps in it, the 301s back in. Like I said, even if one is buggered, I have one extra spare anyway. And when I tested them on the breadboard yesterday, look, I know that was a basic test. All I was doing was putting two resistors. Look, it was kind of telling me 2 things, right? Because I create a virtual ground point and resistors have tolerance, that ground point's not perfectly 0, right? So it's got a little bit of offset to it. Now, if you know what you're doing and you mess around with the pins, you can make the op amp flip from one side to the other. But also, if the op amp's got a huge amount of offset because its input section's damaged on one pin, when you do that the other way around, so to speak, you'll notice that, how do I explain this? It either won't change states or it won't change state to the voltage level that it's supposed to, and you'll know something's wrong with it. So I did a few tests. I didn't just do that test on the video. I tried it the other way around. I also tried it with some 10K pull-up resistors to the rails, and I tried a few different things, and I had the scope on the output, and they all seemed to be working. I didn't go and sit there and put my multimeter in millivolts mode and measure input voltage between pin inputs and all that sort of stuff. But from what I can tell, like I said, they seem to be functioning. So yeah, I'll report back to you guys soon. Hopefully we finally have a supply working, and then we can get on with other stuff, and then in the future we'll do more upgrades to it than what we've already done. But I can tell you now, that side that's working, it worked bloody beautiful. I'm happy with it. It's got perfect regulation. Seems to be super responsive. You know, I was able to calibrate everything to a level of accuracy that you'd expect off of something digital. So, not digital, but with a digital readout. Yeah, so I'm very, very pleased with it. So, I'll do the same to the other side, and we'll report back soon. Cheers. I think I'll upload this video now, because hopefully it's going to be the second last part, and then everyone can see what's going on, because it's already getting late in the afternoon. And when I've finished the entire thing, then I'll make a video about that, and that should be it. And then the videos won't be too long either. So thanks for watching, and I'll see you in the next one, which will be tonight. See you guys.